All right, so we'll just continue now. Last time we went over the exam one, and then we started, or we went back and looked at this functions assignment, and we did the generate a web page problem. And today we have classes we can start looking at 26. So let me do that. I'm going to jump into that to keep on the schedule. If we have time, we can go back and look more at the functions problem again. Is there any pressing questions about functions? Anyone that really wanted me to cover something that they're waiting for? No? Okay. All right, so let's talk about this thing called classes. There's another, these are exercises that you need to do. So another term for classes is user-defined data type or complex data type. Even though sometimes they're referred to as user-defined data types, but there are classes that come with the compiler that are predefined. They're still classes. So you wouldn't think of those as user-defined data types, but you can look them up. You can examine the details in the header files, what those classes look like. So you know we have an int and string. A string is an example of a complex data type. In a string, we use dot notation to access special operations that are associated with that data type string. So, for instance, we can define a string S, and we can print the size of the string. So that string has size 2. There's 2 characters there. There it is, 2 characters. But normally, this is a special case. String is a special case, and it allows this sort of form here of assignment. Normally, when you create an instance of a class, say S here is an instance of the string class, normally the syntax looks like this. You have the name of the data type first, string, or the name of the class, followed by the variable name, the name of the instance name that you want to give the class instance, and followed by a parenthesis, an open parenthesis, and then a list of 0 or more arguments. And this constructor, we call this a constructor expression or constructor function. This takes one argument, which is the characters that the string should be initialized to. And then the strings have what are called the overloaded operators. So we could do something like, hi, Alice. So this is an append operation. So we initialize the string S to hi, and then we append space Alice period. So it should be a length of 9 now. Or we could print the string too. Hi, Alice. There we go. This is called an overloaded operator. We're not going to look at defining those. They're part of the string class. But we're not going to look at defining those in this class for our own classes. However, we will look at we will look at defining functions such as size that we access through the dot operator. So that what I've highlighted right there is the dot for the dot operator. So this is an operation. We want to retrieve the size of the string S. Okay. Let's, so we're here, so string is a data type, a complex data type that has these associated operations that are invoked through the dot operator. Now the string class comes with the language definition. So if you have a compiler that's compliant with the current definition of C++ language, it'll have a string class. But then we can define our own classes. We can define our own data types. And that's what we're going to practice doing in the next couple of weeks here. So this lab has to do with learning how to define and use your own data types. And you'll see in the exam 2, which is coming up, that that there are questions that are similar to the assignment. So here's a question. This is a class called bean jar. These are the functions that are in this class. These are the hidden member variables, the data that's encapsulated inside instances of the class. And this is a description here of how the data type operates. And then there's questions related to that. And so here in this exam, you're asked to define a data type called bean jar. It's instances of the bean jar data type, or instances of the bean jar class. I'm using those words interchangeably, class and data type. Instances of the bean jar class are used to represent bean jars, simplified representations of bean jars. Just what's the maximum number of beans a particular bean jar can hold, and how many beans are currently in there. Of course, beans would have to be less than or equal to max beans for this to make sense. And whether we impose that constraint or not, that's up to us, and whether we get it in the code or not, one way or another. And then there's these functions. Like when we create an instance of this bean jar class, this is actually a function that's called the constructor. So this is a function that's used for creating instances of the class. We call those objects. Objects are instances of our user-defined data types. So so how might this look? It would look something like this. We would use the class name bean jar just like we would use something like string S. So bean jar bj, say. And the string S is initialized to high. But the bj is initialized to 125. Oh, what is the one? So this bean jar constructor takes 2 arguments. This string constructor takes 1 argument. What are the 2 arguments? What are the meaning of the 2 arguments? Well, this constructor arguments are used for initializing instances of the class. In the case of bean jars, the first argument, we can get a hint of what that means because the parameter name is max bean. So it's the maximum number of beans the jar can hold. So the maximum number of beans this jar can hold is 100. And the second argument, our parameter name here is beans. So that suggests that that's how many beans are currently in the jar. And so there's 25 beans currently in the jar. So it wouldn't make sense to do this, right? But in the past, we haven't checked for this inconsistency, but we could. We could start checking for that. So after you have this bean jar, what can you do? We can retrieve the number of beans that are in the jar using the dot operator. I think this should be get beans. I'm just going to guess. Is it get beans? There it is, get beans. Get beans is a function that returns an integer value. It's a function that when it's invoked resolves to an integer. So this expression here resolves to or is replaced by an integer. And in this particular example, it should be, if we implement the code correctly, it should be replaced by the number 25. So one thing we can do with these bean jars is to get the number of beans in the jar. We can add beans. There's add beans. Add beans is a function that we access through this dot operator. We pass in the number of beans to add to the jar. So we could do something like this. BJ, that's the name of our bean jar, add beans, say 20. We're going to add 20 beans. So what is this going to print? This will print the number of beans in the jar, which should be 45.
Will that actually run?
No, because we didn't define the class. This is not a predefined class.
Okay.
We have to define this. That's what we're going to do next, is define bean jar. Let's go ahead and do that. How do we define the class bean jar? We start with the name class, the word class, the name of the class, and then open a brace here. And then close the definition with the closing brace. Don't forget the semicolon here. Unfortunately, that's necessary. That's too bad. Other newer languages don't require that semicolon there. And these data types, they have an external API, which we call the public interface. And then they have stuff in there. Then they have an internal sort of API, or an internal interface, or internal data. And that's comes in this section which is labeled as private. And the external interface to the class is in a section labeled as public. And that's how we do it. You can actually mix these. You can go public, private, then public, private, or you can do private, private, public. There's a lot of flexibility there, but this is how, I think this is the typical way to do it, is to list the public elements first. The public member, they call them members. There's two kinds of members to a data type, two kinds of members to a class. There's member functions and member variables. Here is the declaration that I'm getting to here. See, right? So far we have listed the class with bean jar here, the public declaration, the private declaration, like that. And these are the functions that are in the public section. You can also have variables in the public section too. Many people consider that bad practice. I don't necessarily think it's bad practice in all cases. And in the private section, we have listed two variables. These are not function declarations. Those are variable declarations. There's no parenthesis to show a function call here, or function, or a parameter list for a function. These, you know that these are functions because they have parameter lists. Here's a parameter list that's empty. It's just opening and closing parentheses. It's a parameter list. So the compiler knows it's a function, even though it doesn't take any arguments. It doesn't take any parameters. Now the private section doesn't have to be only member variables. It can also have member functions. Those are privately accessed. The thing about public and private is you've got code that's considered to be inside your class and code that's outside the class. Code that's outside the class can only access the public members of a class. Code that's inside the class has access to both the public and private member variables and functions. So it's a way to control scope. And we do that to increase the readability. Because certain things are meant to be hidden. And we want to be explicit about it. So when we're working with a class, we know that such and such a thing, that max beans is a variable that's hidden. We can't access that directly from code outside of the class. When I mean code outside of the class, I mean code that's outside of any member function in the class. All right, let's keep going here. So here, this code will fail to compile. Well, the dots don't make sense. But we haven't defined the two functions that we're using, or three functions. This is the constructor function here. This is how you call the constructor. Constructor function is called differently from other functions. The other functions are called with the dot operator. But the constructor function is invoked or called by using this syntax, which is to start with the class name, followed by the variable name that you're going to label the instances with, followed by a parenthesis and a list of 0 or more arguments. So the constructor function has that unique syntax. All the other functions that are member functions of the class follow this format. You'll have the name of the class instance, bj, dot, and then the function name, followed by a list of arguments. All right, let's take a look here. Let's define the constructor. So the constructor function always has the same name as the class. And that's common in most languages, not just in this language. So by the way, what we're learning here in C++ is pretty much the standard across most of the modern languages. Some languages have different syntax for defining classes. But a lot of languages, especially the major languages, look almost identical to what we're going to be working with, like Java and C# in particular. Let me take that back. Java and C# are widely used languages which have a syntax that resembles the C++ syntax. But other languages, the syntax is going to vary quite a bit. Like a Python is different. And then PHP is a web development language. The syntax is going to look different. But the concepts are the same. Concepts are pretty much exactly the same. Now, some languages like JavaScript, underlying concepts are different. So you got to be careful there. But concepts that we're learning about languages, objects, object-oriented design are pretty much the standard, or they're common to the most widely used languages. So to define the constructor, we start with the name of the class, and then we have the parameter list, just like a regular function. And we're just declaring it, we're not implementing it yet. So I terminate this with a semicolon right there. So I didn't open the braces and have functions listed there, or having statements. And so there's no statement block for this function. It's just a declaration. It's not a definition. When I use the word definition, it implies that there's a statement block that has the statements that are executed when the function is invoked. All right. Let's get the other ones in there. So we have add beans. Add beans returns an integer. Oh no, it doesn't return an integer. It returns a bool. Because if we passed in 1,000 beans to this jar that we're trying to construct here, we want it to reject it. So we return true or false. False, you're trying to add too many beans, I couldn't do it, or true, the bean number that you gave me is good, I added it to the count of beans in the jar. So we use the bool to pass that information back to the calling code. So we do add beans, and then we have the argument list. What about get beans? Get beans returns an integer. How many beans are in the jar? I'm going to add something here, const. That was in this declaration. There it is. That means this function, this member function, is for information purposes only. It cannot modify the state of the bean jar instance. So it's just a read-only type function. So tell me how many beans are in the jar. So we tell the compiler that this function, we intend this function not to modify any of the member variables in the class. So we use the word const for that, it means constant. We can't add that to add beans because add beans, the intention of the add beans function is to change the state of the bean jar instances, is to change the number of beans in these jars. So we cannot describe those as const. All right. And for private data, we need to keep track of the max beans and the current number of beans in the jar. So we declare two member variables, max beans and beans, in its private section. Like I said, it could be in the public section. But there's a certain style that goes with object-oriented design where we hide the internal data from the outside code. And so I'm just following that sort of common style. But it's not always has to be followed like that. So this bean jar, this class, this BJ is a label for an instance of the class. We could do it like this. We could have BJ1 and BJ2. BJ2 could have the same capacity with 0 beans inside the jar initially. So now we have two instances of the class. So we have one class definition, but we can have multiple instances of the class. Just like a string, we can have many different strings. Each string has its own, we usually label each string with a different variable name. All right, this still will not compile. It'll compile, but it won't link. It'll compile because the functions that we're calling here, the two constructor invocations and this add beans and the get beans invocations, these functions are declared in the class declaration, but they're not defined. We don't provide statement blocks that define how the functions operate. So when the compilation is finished and then we pass to the linker stage, the linker is going to say, hey, I can't find these functions. You said we're there. You said that these functions are there. I cannot find them. I cannot link to them. So I get to link it. You'll see it. It's an LD error. It's reported as an LD error. Undefined symbols, see LD. So we know it's a linker failure. Undefined symbols, add beans is an undefined symbol. It's a declared symbol. Like see, if I took add beans out like this, I would get a different error message. It says no member named addBeans. See, that means I didn't declare the function. And this is caught at compilation time, not at linkage time. And you see the linkage errors have gone away because it didn't bother to link. It said, I'm not going to bother to try to link. I mean, I couldn't compile it. So how can I link something I can't compile? So that's the difference. This is where we declare with this code right here, we're declaring what the data type bean jar looks like. And the compiler says, okay, the way it looks makes sense the way you're using it down here. So I can generate the object code. And then when it's done doing that, it's going to pass the job on to the linker, and the linker's going to say, hey, where's addBeans? Where's getBeans? Where's the constructor? None of those are defined. There it is there. See, addBeans is undefined. This is the constructor, bean jar, that's undefined. Now look at the way it lists addBeans here. It has bean jar : addBeans. So this is a namespace prefix or data type prefix. So the function is called addBeans, but addBeans can be defined for other classes too. You know, you could have a bean crate, you know, and then the bean crate class could have an addBeans function. So we can give them the same function names. So we use this prefix here to say that the addBeans function we're talking about here is a member function of the bean jar class. Like it shows the data type here, int. So addBeans takes an integer. And notice it didn't, here, when it does int, it didn't use beans. It just put an int there. It didn't say int beans, did it? Because beans, this name doesn't matter. When you declare this, we could give it any name we like, or omit the name. Name is optional, because the compiler doesn't need to know the name at this point. The compiler needs to know the name when we define the function, when we provide the statement block, because the statements in the statement block for the function will reference that name. And so we need to give it a name at that point. But when we declare the function, we don't need to give the parameters names. But we do that normally, almost always, because it makes the code more readable for humans. All right, so let's go ahead and define these. Let me show you how to define them. So the bean jar constructor, let's start with the bean jar constructor. The bean jar constructor, the name of the constructor is the name of the class, bean jar. And notice that the code is case sensitive. I have to use uppercase J, lowercase a like this. I mean, we could have called the class something else. We could have used lowercase b. Then we'd have to use lowercase everywhere. But the convention in this language is to use what's called upper camel case for class names. Well, it's not a strict convention for C++, but in other languages, it's a more strict convention. So we get uppercase B. The B is uppercase because it's the first letter. And jar is like a separate word. Right? So we make that uppercase. So we call it camel case. It looks like a camel. Pumps. This is called upper camel case. This is called lower camel case. Actually, lower camel case. Upper camel case means you start the identifier with the uppercase letter. Lower camel case is used for the member variable. See the M in max beans? That's lowercase m. We still have an uppercase b here, but we start the name with lowercase. That's called lower camel case as opposed to upper camel case. And this member variable has only one word in it, so it's all in lowercase. That's the convention. So we'll stick to that convention in this class. And like I said, it's the common convention. So To define the constructor, we use the class name beanjar, and then we list the member, not the member, the parameter list, and then we open up for the statement block using braces. The braces enclose the statement block, and let's just for now, just make a note that we have to do something in there. So we're going to implement what's called a stub here. The stub is when you have a function that's where you start the definition of the function, but you don't do anything in it, or you do something trivial in it. And this is just to see if you can get the code to compile or to run somewhat. This is not good enough because beanjar is a function within the class beanjar. So we need to qualify that with a prefix, class name prefix. We use the same format for add beans and get beans. Beanjar : add beans. Well, notice function names use the lower camel case naming convention. Once again, we're going to define a stub there. We're not going to put anything in there yet. And then beanjar get beans. You have to have the exact same signature, the exact same declaration that we have in other places. So here it's declared as const. We have to use const here. We omit that, it won't compile. Once again, get beans. These stubs are not good enough as stubs yet. Oh, look, by the way, add beans. The constructor function is unique in that it doesn't have any return. You can return from a constructor. You can use a return statement in a constructor, I think. But you can't return anything. The constructor doesn't, we call it a function, but it really is handled differently. Constructors are handled differently. It's where you create an instance of a data type. That's when the constructor code runs. But for functions, functions need to return a value. So add beans returns bool, and get beans returns int. That's what we have declared up here. Add beans returns bool, get beans returns int. That means the stub code has to return something. Let's return true for add beans, and return, say, 0 for get beans. And I didn't do that right. There we go. So we're still missing implementation details for these functions. But I got the code to the point where we can compile and run. So this is a testable unit of work right here, I think. Let's see if that works. It is. It runs. 0. So what do we do here? We print get beans. So get beans just returns 0. We just have a stub there. It should return 20. It should return 45, but it's only returning 0 now. So get beans, actually, all that get beans should do, it returns the number of beans that are in the object. When I say object, I mean class instance. Get beans simply returns the variable beans. That represents how many beans are in the jar. So return beans is good enough for the get beans function. What about initialization? Oh, and look, these names here, this max beans and this beans, these two names are visible to all of the code that are in the member functions. They're not visible to code outside of the member functions. That's why they're declared private. But when we create an instance of this class, we need to initialize max beans and beans. So that's done here. This is the code that runs when we create an instance of the class. So we want to initialize max beans here. Let's initialize max beans to 1. Just picking something silly for the moment, okay? But look, we have a naming conflict. Max beans is a parameter. It's the name of a parameter in the function. And max beans is also the name of a member variable. But those are two different variables. They're given the same name, but they're two different variables, two different objects, two different entities. So the rule is when you use a name, and if there's a naming conflict because it names more than one entity, then the name refers to, the compiler will say, oh, your use of that name refers to that entity whose name is in a more local scope, a more immediate scope. That would be the function argument, the function parameter, max beans. So we're setting max beans to 1 here. We're just clobbering the value for max beans that are being sent into the function. We need to tell the compiler, I don't want to set max beans to 1. I don't want to set the parameter max beans to 1. I want to set the member variable max beans to 1. So we use this syntax, this hyphen greater than. And it's meant to look like an arrow, by the way. And this is a keyword. It's a pointer to the object instance that's being initialized. And we're not going to cover pointers in this class. In the class that follows this, we cover pointers. So we don't need to talk too much about that at this point. You can think of this as a way of telling the compiler, you mean the other max beans, the member variable max beans. So whenever you go this arrow, it means the member variable max beans. And when you omit this, it means the parameter max beans. But we don't want to set max beans to 1. We want to set max beans to the value that's being passed in to the constructor function. To do this max beans equals max beans. Look, the code down here passes 100 into max beans. It passes 100 into the constructor as the parameter max beans. So we take that number, which comes in here, is named right there, it's the 100, and that's copied into this private memory storage area that we also label max beans. So we're redundant. We give the same name to two different things. By the way, we don't have to do that. We could have given this a different name. Then we wouldn't have needed to use this prefix. But what I'm showing you is the most commonly used style, which is to use redundant naming because it's simply better documentation. So when the constructor argument has the same name as a member variable, you know it's going to be a straight copy. So when you see that, you know what's going on. Well, that's why people stick to that convention in general. Not just in this language, but most of the other languages. That's the convention that programmers, by and large, follow. They don't all follow it exactly like that, but in general, that's what they do. That's the current style. And now we got to also initialize this the beans variable as well. See, instances of the bean jar class have a state, and the state is completely determined by the values of max beans and beans. So there's two integer values. We set those two integer values in the constructor, and the state is fixed at that point. And then we can change the state of that object by calling these mutator functions like this add beans. Mutates, it changes the state of the object, changes the number of beans in there. So we can change the number of beans in the jar, but we can't change the max beans because there's no function to change or set max beans. So once we pass max beans in through the constructor, it remains fixed. That's just our design, it's not required. That's just how we wrote the code. We're the ones that are defining this data type. We do it our way. That's how we did it. Now add beans, we pass in a number of beans to add. So the beans that are currently in the jar, which is this beans, we want to add to that the number of beans coming in. And then we return true to say that, yeah, we did it. But what happens if the user code passes in a large number, like 1,000 beans? We want to return false. We're going to check the incoming value to see if it's reasonable. Let's wait on that. Let's do that later. And what we have right now is code that'll make this test code run. So let's print the beans that are in BJ1. Let's print the beans that are in BJ2. And this should be 0. It should print 45 and a 0. There it is. Let's make this solid test code here. So I want this to be automated. I don't want to have to remember that it prints 45 and 0 and then inspect it and make sure that that's what it does. I'm going to use assertions to check those values for me, so I don't have to do visual inspection. After I use those insertions, I'll say all tests are passed. And so how do we do that? We do it like this. bj1.getBeans should return 45. So I assert that bj1.getBeans equals 45. And same with bj2, getBeans should equal 0. And in fact, we could throw in another assertion up here. When we create bj1, getBeans should return 25. And it's only after calling addBeans that getBeans returns 45. And I'll just reorganize this a little bit. Here we're testing the instance bj1. Here we're testing the instance bj2. I'm putting lines in there. So here's test bj1, test bj2. And then if all those assertions pass, then we print all tests passed. All tests passed. We got a problem here. What happens if we do this? Let's add beans, 1,000. Oops. We want getBeans to continue to return 45. because you can't add 1,000. So we have two choices. We can either add as much as we can, and then the number of beans hits 100, which is the max beans, or else we just flat out, don't do it, don't do anything. And I think that depends on how you define the class. When one of these functions fails, the number of beans in the jar will not have been changed. So you can read the rest of that there. Basically, that specification says that if you're trying to add too many beans, don't add any beans at all. And return false. So this code here will pass. Oh, it doesn't. Oh no, it doesn't. That's because we added 1,000, right? That's the problem. We added 1,000. Get beans returns 1,045. So we need to add code that fixes that. If the beans that are in the jar, and this for some reason, well, I'm not for some reason, but it happens to be that coming up with this expression is very hard for students. I've seen this over and over again over the quarters. This is the hard part right here. Just slow up, pay attention to this. How do we express this constraint? Well, this is one way to do it. I think this is the easiest way. If the number of beans in the jar plus the beans that are being asked to add, that are being asked to be added to the jar, if those added together, now this doesn't do any, it just creates a number. It doesn't modify the beans that are in the jar. If this exceeds max beans, then we got a problem. We return false and say, I can't do it. If we don't return false, then we can add the beans in there and return true. And notice I didn't do this. I could have done that. Some people do that in some languages like JavaScript, and I think Python. I don't use Python enough. I think Python requires all the variables, or maybe it's PHP too. Some languages require that these member variables always be prefixed with this symbol to tell the processor that it's a member variable and not another variable, even if there's no name conflict. But in C++, this is optional. If there's no name conflict, and it's clear there's no max beans in the argument list up here, there's no max beans defined in the function block, and so the compiler says, well, you must mean the max beans, that's the member variable max beans, because that's in scope. So you can use the name that's in scope. So in this language, we can do this. If you like to put this in front of max beans, you can do that. If that's more readable to you, you can do that. So this should do it. So here, we're passing in 1,000. So this beans will be 25 or 45 plus beans, which is 1,000. So it's 1,045. That's bigger than 100, and therefore we return false without modifying beans. You have questions? Semicolon is missed. Thank you. Very good. Thank you. That saves us from having to debug that. Let's run it. This code is good, I think. Alt has passed. So this expression here happens to be tough for people to come up with. So you'll need to pay attention to that. Now the other thing is, we want to make sure that we're returning the right value. Like here, watch, we could return true here. Watch that. Why not? It doesn't have any effect. Alt test passed. But this should fail. We need to test the return value of add beans. This call to add beans, when we start at 25 and then we want to add 20 beans, this call to add beans should succeed. So we assert that add beans 20 returns true. And then here, let's just test that. That should be good. I'll test fast. But down here, when we add 1,000, that this should fail. This should return false. Add beans 1,000 should return false. Why should it return false? Because it's part of the problem statement. See, the class provides functions to add beans, remove beans, and get the number of beans that are currently in the bean jar. The functions to add and remove beans return a Boolean value that indicates whether the operation succeeded or failed. So we doing this not because we have to, because of syntax restrictions or anything like that. We're doing it because it's the problem statement. We're going to return false when add beans can't do the job. So we're going to see that in this case, add beans with 1,000 should return false. Here's the assertion failure right there. Add beans 1,000 equals false. Assertion failed. That's because we were returning true here when we should have returned false. Now let's fix it. There we go. So this is how you define a data type. We've got this data type called bean jar. It's also called a class. It has member functions, which are also called behaviors or operations. They're invoked using a dot operator in general, except for the constructor. And then there's member variables, which are used to represent the state of the object instance, of the class instances. These are, following the declaration, we have a section that defines the functions. The constructor is used to initialize new instances of the class, which means, generally, that means setting the member variables to something. And then there are the other definitions of the other member functions, add beans and get beans in this case. And we have test code. In a regular program, you would have test code that runs, and then you'll have the system that you're building that's maybe using the bean jar class, right? But we're not going to that. We're not using that bean jar class to do anything meaningful. We're practicing. It's hard to do meaningful stuff at this point. It's especially hard to do meaningful stuff because of the way the book is organized that we're using. So we haven't covered arrays yet. So we don't have a way to have collections of objects. So it's really tough to come up with meaningful problems that have to do with classes at this point. So we're just breaking the ice here of understanding how classes work, just with some simple code. So we just have a class definition, then we have a bunch of test code. No real meaningful work being done. But the purpose of test code like this, the test code is good. It's not silly test code. This is how your test code ought to look, or something like this. When you get test code that runs, then you know the bean jar class is properly implemented. You can use it in a large system that you're building that's using, say, the bean jar class for some reason. I don't think we did everything. We didn't get remove beans. Let's do remove beans. Let's add remove beans. I'll stumble around and make mistakes. Let's see if you can catch the problem. Okay. So remove beans returns a bool just like add beans. And it's the beans to remove. And then it returns true or false, whether it can remove the beans or not. So there's only 10 beans in the jar, and I say remove 20. You can't do it. You have to return false. So if the beans that are in the jar minus the beans that you're asking me to take out. If that's less than 0, then I can't do it. I can't take more beans out. So I'm going to return false to say that failed. I'm not going to take any beans out. Otherwise, I can take the beans out that you want me to take out. There's the expression for that, minus equals. This beans is reduced by the amount beans. Now this will not compile. Does anyone see why? Huh? Oh yeah, I get a return. That's one reason. Yeah, there's multiple reasons this won't work, and that is one of them. That's the other reason. Yeah, we defined it here, but we didn't declare it in the class declaration. So remove beans returns bool, takes the number of beans to remove. Now this should compile. We don't have any test code for it, but it compiles. Now let's add test code. So at this point, get beans is 45. And let's call remove beans. Remove beans, say 15. That should succeed. And after, let's check that it does it right. So after we remove the beans, it should have 30 beans left in the jar. So we had 45. We tested it here with that assertion. We remove 15, now we should have 30. All right, and then let's try to do something unreasonable. Let's try to remove 900 beans. That should return false. And should we bring it down to 0 or should we just leave it at 30? That's not for us to decide. The boss tells us here in this problem statement, in the specification, the boss tells us, or the client tells us that, or the other programmer who's going to use the bean jar class, and you're the junior programmer, just got hired, that other programmer, the lead programmer, told you, if you can't take all the beans out, don't go down to 0, just leave the beans unchanged. When one of these functions fails, the number of beans in the jar will not have been changed. So it's in the specification. So this is false. And then we want to test that the number of beans has not been changed. Check to see if it's still 30. Looks good. Now look at that. That, in 1 hour, is everything you need to know this quarter for classes. Okay? Well, you got to practice this. It takes a while. But this is not an impossible part of the class. It's confusing. Everybody is confused by this. Everybody. And I got to tell you, historically, it took decades for programmers to adopt classes. It's also called object-oriented design. That's what it's usually referred to. It was a battle. It was like a religious battle. The ones that believed in object-oriented design and the ones that didn't. Well, ultimately what happened at the end of decades, decades, like 30 years, at the end of decades of heated arguments and disagreements, people are all using class, almost everybody is using classes now. Almost all code, new code that's written, is object-oriented. There's still some people that argue against it, and the future may actually, I'm sure the future is going to be different. It'll be like, oh yeah, we all jumped on that bandwagon, but now look at the trouble we're in. They got to come up with another fix because things keep getting more complex. And the procedures and the patterns that we have now, that are working for us at this level of complexity in the applications that we have, and the code that we have, the code base that we've built up, it's working now. But as things move forward, there's always a need for new developments. So, and people are already talking about transcending classes and doing something different. Right? So it's there, it's coming for sure. But this is the state of the art right now. You know, you look at a system with 1 million lines of code. If you're going to build a big system, then you're going to use object-oriented design because it's really messy. If you're going to make a little program, then you don't need this because it may even make it more complicated. Just use functions. And anyway, that's it. Did you have a question?
Yeah, I'm pretty sure we're going to use classes when we get to the raise as well, correct?
We're going to use classes.
Yeah, because I know the next section is going to be a raise. That's what we're going to learn.
Yeah.
We're going to use raise in our classes. Is that what you're going to teach us that? Or?
Yeah, they may need to have a raise inside the classes. I'm not sure I'm going to have any examples of that. We'll see when we get there. Yeah, so we have one more big topic coming up. Well, I want a note about exam 2. I used to have 3 exams and 1 final. So I changed it. This quarter, I'm going to have 2 exams and 1 final. So if you look at these old exams, you'll see there's a 2014 fall-2 and a 2014 fall-3. So this -2, that's the exam that only covered classes that I used in the past. And this exam is the exam that uses the material that comes after classes. And the final is comprehensive. It covers everything. So you can take these and sort of compress these together. So at this point, you can start practicing, looking at these old exams. And start practicing for the exam 3. Once again, our exam 2 will be a merger of topics that are covered by these 2 exams in the past. And what are those topics? Well, the most important thing is arrays. We're going to cover arrays, which are sequences of data. Sequence of bean chart instances, or a sequence of integers, a sequence of strings. And it's more than a sequence. A sequence implies one thing after another. They're sequential in that manner, but they're also you can also jump inside of the sequence at any point. You can index into it and drop down at any point inside it. So maybe we call it a container, a sequential container. And you can access values in the container by an index. So if an array has 100 values in it, you can say, give me the 98th value. And so we'll talk about that. Now, that's the last sort of piece of syntax and language concept that we're going to learn in this class is arrays. That's it. And then it's just a matter of applications. We're going to look at binary search, sorting, and the problem of writing programs that do something meaningful. And so the little programs that we've been writing are silly little programs, just practice problems that don't really do anything meaningful. So at the end, we're going to build a tic-tac-toe game, and which will do something meaningful. We'll be able to play tic-tac-toe with the computer. I mean, even that's not meaningful. But who wants to play tic-tac-toe with a computer, right? So it's still pretend. It's still pretend. But we're pretending that it's not pretending, I guess. So that's what's coming up. And so just jump into that. Any other questions? Yeah.
It's about like the later class called data structures. Is that all we do?
Data structures?
Yeah,
Yeah, data structure is going to focus on things like arrays. Like arrays is called a container. It's a way of organizing data. But you can organize data in different ways. You can have trees. You can organize data in terms of search trees or heaps, priority queues, graphs. You can represent data using graphs where you have nodes. The nodes contain some kind of state, and they're related to each other. You can go from one node to the next through a link. So different ways of organizing data. That's what data structures is. And then it's representing data in different organizations, but also the algorithms that are used to process that data. And that's one of the key classes in all computer science programs in the world. I mean, that's a very important and critical area to learn. So this leads up to data structures. And this language, in our program, we use C++ in that course. Did I answer your question? Yeah. Okay. Anything else? Yeah.
Kind of not relevant, but the people that don't believe in classes, like,
Yeah. They're dead, by the way. That happened a long time ago.
okay, you kill them off.
Yeah, we didn't kill them. They got old. It was a long time ago. But go ahead.
Okay, I was just wondering like what they do now, but they're dead. So
You know, I don't know that much about it because I think there was a university. I'm trying to remember a famous university where the faculty were advocating. They refused to use object-oriented design in their required programming classes anymore. Right, so they would teach this class without. But there's only one university. I can't remember which one it is. I think it's, wait a minute, Carnegie Mellon maybe? I don't remember, somewhere. I read about it. And so what they're advocating, I'm not doing research in that area, so I can't answer the question. But you might want to look it up. Yeah. Anything else?